Okay, so what's up guys? In this video, I'm gonna finally do what we've been talking about doing for a little while. I've been trying to get my whole setup working and just synced up. I was having a little bit of trouble with the camera. I'm actually using my iPhone as a camera right now, so let me know if you guys like the photo quality. So in this video, as I mentioned before, we are going to do an EDA, which is an exploratory data analysis, and we're going to be doing it on COVID-19 data from worldwide. Now, to tell you a little bit more about the video, it's just going to be a short little EDA. It's not going to be too much in depth. This is really just a beginner's look, basically, and I've been trying to find different sources that have done similar things so that I can copy and learn the best practices. But for now, I've been working on this COVID one, so let me know what you guys think. So let's get started. The first thing you're going to want to do is have Jupyter installed. You can find other videos on that. I'm not going to make a video on that, but it's really easy. You just download Anaconda and then start up Jupyter Notebook and you're ready. Next thing you want to do is get the data, of course. So I'm going to show you how I do that. Basically just go to a website and we're going to be getting our data from the EU open portal called europa.eu, and just right here you scroll down, you get the worldwide cases in a CSV file, which is what we're going to be using. Now, one important thing to note is that this stuff is actually uploaded every day. So the last time it was uploaded, it was actually, oh sorry, right here, is today. Actually, never mind. It hasn't been updated in a month, so my bad. But it's, it's fairly recent. So let's go and download this. Gotta save the file. Cool. And I'm just gonna drag it onto my computer. And in this case, I have to name it as a CSV, which is super easy. Perfect. And we're done. I put it in a folder, so it's kind of the easiest part, getting the data, although it could be complicated sometimes. This data is what you would call structured data. It already comes in, rows and columns. It's not unstructured like, something like voice or what else? Pictures. Yeah, pictures and stuff. So here we go. It's already popped up here in my Jupyter Notebook. It's got a weird name. I should really rename that. But it's okay for now. I'm just going to copy paste that for now. Save me some time later. So here we go. Open up the notebook. And let's start. So let's just write exploring. Oh, actually, I'm going to mute my keyboard. Alright, so I just muted myself really quickly so that you guys don't have to hear my keyboard. It's really loud. It's right next to the mic. But we're just going to mute for now. So here we go. I have imported all the important stuff. I already know what I need to import because I've done it before, but usually you import everything first and then you continue. So I put it at the top. These imports, I have pandas, which obviously you need to work with data frames, and Python, we have matplots, all sorts of matplots, and I imported IO to help us. So now I'm going to read our file, or at least load our file into the awesome. So here I wrote the command to read the CSV file and make it into a data frame, and we're actually going to be calling it df, so we're just going to calling it data frame. So we actually got an error, and let's see why that is. It seems like it can't find it. Oh, see my mistake. All right, there we go. And now we have it loaded up with no error, so let's move on and see what the data frame looks like. All right, so here loaded up data frame. We got just the first 10, and we can see on the top the columns we have date reported, the day, the month, the year, the cases, the deaths, the country and territories, GOLD, which I'm sure means, like, since it's Afghanistan and this is AF, it probably is just like the country code. Oh no, country territory code. So I wonder what this means. Population data. Whoa, that's actually 38 million people live in Afghanistan. Okay, cool. Continent, and here we have cumulative number of 14 days of COVID-19 cases per. We got 10,000. Cool. So that's what we're going to be working with, and let's see. Let's see how long this stuff is. So cool. So now we know how long it is. Basically, this is the amount of rows, because we already know that it has like 1, 2, 3, 4, you know, it doesn't have more than 10 columns, but it has 38,000, almost 39,000 rows. So that's how many times things were reported, which is cool. Let's see what else we can find. Beautiful. So I used describe, and we now have a cool little table that has almost all the summary statistics that you would need. Funny enough, this isn't always, you know, good to follow through. Just like, don't take it always like as granted, because right here we see that with cases, there's a minimum number of cases of a negative number, and we also have negative deaths. So unless we have like zombies, I don't know what the hell's happening here, and I don't know what's happening here. So I'm not going to take this as for granted. The year, yeah, you know, this doesn't really tell us anything. Standard deviation doesn't tell us anything. Months, days, mean. Alright, so nothing really stands out other than basically just these negative numbers, which we know do not belong. So we can guess, we can start to, you know, think about why this might be. This is probably either a misreporting, typo, or it could be that our country decided to fix a mistake that they reported before. So we'll see what country did that later. So let's move on. Alright, so here we get the info for a lot of different columns, and we get the values, how many non-null values there are, and their data type. So date is an object, which we know. Day is an int, years an int, cases is an int, deaths is an int, country and territories is an object. Population data is a float, which, I mean, seems kind of pointless because we can't have half humans. We have zombie humans and we have half humans in this data set. And then we have the continents object. Cool. And then we have a float for cases. Oh, and that's probably because it's per 10,000. So I guess that's okay. Cool. So this gives us the shape, which again, we kind of knew. So apparently it's got 12 columns. And like we mentioned earlier, it has 39,000 days reported. Or reports, not days reported, reports. Cool. Let's see what else we can do. Well, let's start by getting all the columns. Cool. So now we have an easy way of selecting all the columns. We just write columns or calls, and we have the columns. And yep, here we go. We have them in a list. So if we wanted to do something like call the first one like date, we can do that just by slicing. So all right, so here we go. We called the date rep just by the date rep name just by writing calls 0. So that's just for easy access for next, for our next steps. So next, I'm going to... Cool. And this is the opposite of head, it's tail, and we have all the data from Zimbabwe. So if I scroll up, with the head, we got Afghanistan and stuff. So it seems like it's in order by country. We don't know that, but Zimbabwe is all the way at the bottom, and Afghanistan's all the way at the top. So it must be in some sort of order. Oh, look at that. We have some number not available. So cool. So we're probably gonna have to deal with this later, or maybe not. I don't know how far I want to go in this video, but here we go. At least we know that Zimbabwe has some of those values missing. Cool. Next, let's call just like a date to... Cool. So here we called the date rep head just by using the dot notation, and we only call the first 5. We can change this to 10 if we like, or 15, and here we have it. And it also tells us that they're objects. This is not in American format, this is in European format, which, I mean, doesn't really make a difference as long as you know that. I make those mistakes all the time, so... Cool, so here it is exactly the same thing, I just called 15 instead. This is just to show you the other notation we have in pandas, but I mean, this is basically just a waste. I just wanted to show you guys how to do that. And so next we're going to see a little bit about cool. So simply, as you saw there, I had to look at what the case's name was, because it turns out that you can make an easy mistake here and write a capital C like I had earlier, but I made sure to check that it was a lowercase. All of these are lowercase. So that's important to know, because you will get a mistake if you use the capital here. So I had to make sure. And here we're describing it, and here again you see that negative number, so that's not good. We actually get 0 for the lower 25. 7 for the middle 50, and 128 for the 27%, with an enormous max. Wow. I wonder what country had that. Alright. Alright, let's think about what I should ask. Well, let's find out how many countries reported, because I think that's a good thing to know. Cool. So we did that. And here, actually, because it's an object, it looks like it gave us a very interesting case of unique and the top and the frequency. So the describe changes depending on which object type it is, or data type it is. Yeah, so it gives us the total count, or basically the total rows, which is a number that we've seen multiple times. That's the 39,000, but we have 210 unique cases, and 241 is the frequency, and the top one is Canada. But we might not know this for sure, because what if many countries reported just that exact amount of time? So let's see. Alright guys, here we have it. Really need to get better at spelling and my little mistakes, but that's fine. Luckily the computer tells us when we made an error, and we can fix it. So here we go, I fixed it, and we got the most common one, and then we got all the different countries. Printed in a list. So actually this is good, because now we know what it's called. So we can call the United States of America if we wanted to. It looks like they use underscore. So, I mean, I probably would have made that mistake of not using underscore, but, well, that's why we check. So here, all I did was get the countries reported unique, and I printed the length of that, and then I got the countries' names and the reported. Cool. Let's see, what should we do next? Let's see how many times the US reported, or at least let's find out more about the US. So alright, so I actually forgot how to do this, I had to look it up, but what I'm doing is a mask. So I'm going to try to see which cases of this data actually have US in it, in the row, and then I'm going to get those rows. So that's actually called a mask, because I'm masking it to like a true or false value. and grabbing all of the ones that are true. So watch how I do that, actually. Okay, so I think it worked. I had forgotten this, that we can select a data frame column and see when it's equal to United States, and we easily get then all the rows that we want that are from the United States. So an easy way to do this is to visualize. We wrote countries and territories, and then we wrote US, or is equal to US with the two equals, and we got true or false. Do that, and that's what we did. It's easier to visualize like this. So we got this and we got this. We could have also done country territory code. That would have been easier, or even this, but we didn't. We did it this way. So nice. Now let's see which are true. Alright, so here I made a mistake that you guys saw earlier that I double checked. Well, I printed out the data frame using the ones that were true from the mask, and I got nothing. And that's because there's no country that's United States of America with a underscore, with a lowercase s. So you always have to make sure, like I mentioned earlier, that you do it right. So here it is. I'm just going to copy paste it this time. And now I have to rerun this cell and the one. Bam. Alright, so a mistake, but we're able to catch it really fast. Here we have all the countries that are US only, and we have 241 rows. Alright, I was just looking here. We have a couple of no values. Oh, actually, this is in January. So we have nothing in January. By we, I mean the United States. And then the cases per 10,000, or 100,000, sorry, ends up being 203 by August. Cool, and wow, that's really high. Almost 1,000 deaths. Oh, so actually this data is super recent. It goes all the way to the 27th. Cool. One thing to notice is the population. This is the largest population I've seen. I mean, other than maybe China, but we got 3. We got almost 330 million people in the US. That's a lot. Cool. So now let's move on to, I mean, it kind of tells us how long it is, but let's see how many days we reported. So how many different rows there are. Cool. So yeah, we already knew this. It said it right here. But just so you know, you can just do length, and we see how many rows. Kind of pointless in this case because I just mentioned. Cool. So I wasn't sure if this would work, but it does. we can actually get, we call here the data frame of the US with the cases, and we add them all up. So, I mean, this is perfect for us. We get the total amount of cases. Oh, wow, that's a... Alright, it's not that big, but it's 5 million, actually. That was much bigger than I was expecting. It's a lot. Okay. Cool, so now we know that. Let's see. So we already know the population, but we can call that too by just calling it up. Alright, so here you can see that I made a mistake. This number doesn't, equal this number. So the mistake I made here is I wrote data frame and I didn't call the data frame of the US. So I'm going to fix that right now. See if I can get the right number. Cool, sorry about the keyboard, I forgot to mute there. Yeah, here we go. Cool. If we were to add all this up, we'd actually see a mistake, because every time they kind of write the same thing, they don't update it actually as a person dies. So we see the same number again and again and again from the very beginning to the very end. Cool, so now let's see if we can write a little bit of code to see some graphs. Now, let's start with just like accumulation. Awesome, so there are a little accumulate function that we're going to use next to do the graphs, and you'll see why I use that. It makes things much easier. So let's actually test it to see if it works. Cool, actually it works perfectly fine. I've written this a lot, so but I always make so many spelling mistakes. They're easy to find though. So here we go. We accumulated 1, 3, 6, 10, 15. Perfect. Now let's see if we can make a really easy graph. Okay, so what I've done so far, because I think it's important to mention, I'm writing a function, a very simple one, to graph. In this data, we kind of need to do a little bit of work in order to make it, I guess you can say, in order, so that we can do a kind of a line plot or a line graph. And so an important thing here I wrote is to get a list and get the list of the country's cases, correct? And make the list backwards. So this is important because we want to start off from the end. We don't want to start from the beginning. And in the data, we can see how each time the date is the most recent date and the oldest date is the first date reported. And so we want to turn that data around. So we can very simply do it using this method. And it's important to, or using this expression. That's funny, this method. All right, so that's what I'm going to do. And I'm going to do the same thing for deaths and the dates, because again, we want it to start off not from the most recent date, but from the oldest date. Cool, and there you have it. That was pretty simple. I just copy pasted. The first time it was a little bit tougher. I was thinking about it. And the second time, I mean, I just copy pasted and replaced the cases with the different columns that I wanted. And I think that's all we really need for the graph. Let's see. We can have issues with our nan or our non. So it's not null, but the nan is not a number. So let's work on that actually. Cool. So we have it here. This was actually pretty easy. So if we're basically looking for when the population is nan, and if it all of them are nan, like literally like that here I wrote the highest number is nan, then basically we have a case that the country doesn't have a population. And I wonder, I didn't check to see if that's actually the case for any of them, but it might be. And then I got the else, right? So for the ones that do have a max, make it into an int, and let's see if I wrote this right. Yes. So get the max number. And as we saw, I mean, at least in the US, there wasn't any updates, so I could have just grabbed any, but I just grabbed the max to be sure. So here we go. Perfect. Now we have the DF, we have the country, we have the population fixed, and now we got to do the cumulative. This is going to be for a cumulative graph. So if we want a non-cumulative, we can write false. But if we do want cumulative, we can write true. False. Let's just, let's see if we can plot this now. Alright guys, so I didn't actually have to add. I mean, I guess I did, but I forgot to add the colors. So I did that, and I made it so that we have the dates and the cases for the blue, and we have the dates and the deaths for the red. So this is the US. This is very interesting to see the graph like this. Actually, it's going up and down, up and down. So there must be either weekends or something going on, or here. Probably not holidays, but wow, what a spike there. Now, I actually can't see the dates because there's so many dates. It's every date, actually. Since basically the beginning of this year, we should figure out a way to make this better. There's a lot, though. Yeah, so I'll think about that. But that is something that happens quite frequently, so I guess I'm gonna have to start thinking of different ways to do that, and I'll do that kind of in the next video. But for now, I think this should be good. I don't want this video to get too long. So here we have, oh, we don't have the title or anything. Let me do the title and stuff, and then I'll end the video here, and for next time I'll go in more depth. So let's do that. And cool, let's do that. Cool. Oh gosh. No, I don't know if I muted or not during all of that. I'm sorry. Well, here we go. I did it. I made the title, reported COVID-19, and I don't know what else you can include. Anything else you want. You can make it bigger, smaller. But here I have basically a really simple case. Now, we could do cumulative, I guess. I did say I was going to end the video. But, you know. Alright. I'll add it. Fine. But after this, for sure, we're good. Okay. Let me not mess this up. Here we go. Alright guys, so pretty simple what I did here. If it's cumulative, so here I gotta make this true. Let's do that. I could also call it down here. I don't know why I'm fixing that, I'm sorry, but I did that. So if it's true, if cumulative is true, we have the cases, and we accumulate the cases, and we accumulate, so let's see what that looks like. So remember this graph, and now we're going to accumulate the graph, see what we get. Oh, there we go, perfect. It's really smoothened out, but it's straight up. And really small here on deaths, which is good, but we don't know. Oh, we didn't even work on the scales either. But here we go, this is cumulative, and the other one was the non-cumulative. Here we go. So that's it for today's video. It was already getting pretty long. Next time I'm gonna show a little bit more in depth some things, and I'm gonna see if I can show more graphs or do any functional programming. But that's all for this week, and yeah, I'll let you guys know more about what my next decisions are going to be for this data set. So I hope you guys enjoyed and enjoyed this very beginner's look at EDA analysis, and you guys should try it out. I'll leave a link to this below. I'll leave a link to where I got the data and where I got the idea to do this EDA, and some of the code that I also got from there that I practiced and used in this yeah, in this what is it called, in this project, in this notebook. So awesome. I hope you guys enjoyed, and I'll see you guys next time. Peace.